For the process, a little less of me, okay? Is it recording it?
Yeah.
Okay. So I'm gonna actually start this reaction up for you, okay? And I'm gonna tell you why we're gonna go over this reaction, because I'm gonna be building a heater for you guys that you can actually use. And I have a few farmers who are really desperately trying to learn how to do this right now. So the best way that I figure is
Are we not losing some of the hydrogen from the top? You know?
No, it's all-
Is it from here?
the
Or is
reaction-
it all coming from the bottom?
The reaction's being captured by these two test tubes, okay? So I'm gonna turn this on, and would someone mind turning on the lights so that everyone can kind of see a little better? Thank you very much. And you can actually, wow, immediately. And just, we were having a really slow crawl with the aluminum, but without the aluminum foil at the top. Now you can actually see these bubbles coming out very vigorously. I'm actually gonna be lighting these up for you here in a
Are
moment.
one leads in one tube, the other one's on the other?
Yes, so oxygen forms here, hydrogen forms there. So
Oh, okay.
if you don't know anything about what water is, it's actually two atoms of hydrogen and one molecule of oxygen, or one atom of oxygen. So think of kind of like a Mickey Mouse balloon, okay? The two ears are the two hydrogens, and, well, the face is the oxygen. Now, it turns out hydrogen is an extremely flammable gas. As a matter of fact, nothing burns without the presence of hydrogen. Even oil actually has hydrogen in it. The problem is that it also has carbon in it. So when it burns, the carbon mixes with the air and makes a carbon dioxide, which is a problem. And when you burn hydrogen, however, the only byproduct is water. And not to mention, though, hydrogen is also the most reactive fuel on the chart, meaning it has the highest energy available for fuels.
Now,
Okay?
is this DC you're passing to it?
Passing DC.
Will it work with AC?
It will, but then what will happen is that it mixes its transition. So it turns out hydrogen loves the negative lead. Okay? So if you use AC, it'll make hydrogen on this side and oxygen on the other side and then switch it. That's what AC is. It's a switching polarity.
Is there any reason why oxygen goes to the other side?
Because
Yeah,
oxygen
attracted to
actually has a lack of, or a surplus of charge. So this
It's the
is,
valence electrons that
Yeah.
determine where it goes.
that's correct.
Okay.
So in technicality, what we're talking about in simple layman's terms is the electricity acts like a magnet for the molecules, pulls the molecules apart. So what you drink can actually turn into a fuel. Now the beauty is after you burn the fuel, it turns back into pure and actually extremely pure water. Okay, and we're talking about the problem-solving solution. This is an engine, a diagram proof of an engine. You need about at least a 2-to-2, so oxygen to fuel ratio in a cylinder. Okay, and what happens is the fuel is drawn in when the plunger of your cylinder goes down. It pulls the fuel in, and then on its way back up, the valve closes. A spark goes just like this, like that. Okay. And it causes combustion. The explosion pushes this plunger down, causes this to turn, which is transferred to your wheels, and then eventually when on its way up, it releases the burnt gas, and that's exhaust, which is actually causing us a problem, okay? So the problem solution thing, we kind of think about the calculations, the steps, and all that. And I'm not going to get back to that because, well, right now it's winter, and this morning I actually filmed my crops. I grow grain and tomatoes. Well, there's frost, okay? And what frost does is actually destroys the plant's leaves, stems, and their ability to do photosynthesis, essentially killing them. Frostbite, okay? And what I'm going to actually show you, using a couple of things that I brought with me, snacks, okay? I brought with me some toilet paper. These look like peanuts, but they're actually rocks from my driveway. Okay. And I'm actually going to be forming a heater. Okay. So this heater is actually not something new. It's been around for quite some time. Get the lid out.
Is there a name for what it's called?
The technology it's related to is kind of a Cornish heater. So we would almost say that the homeless invented this heater, or the soldiers of World War II invented this heater. Hasn't been around for some time in discussions. Okay, so what I'm going to do is take this soup can here, remove the label, Now, the label is going to get a little charry from the temperature. It's okay. So I have a few farmers, including myself, who are saying, you know what? It's not time to lose all my crops yet, okay? So what we're doing is we're talking about turning something like this into a heater, okay? Now, the cost of propane per ounce is about 26 to about 45 cents an ounce, okay? Now, using the fuel that I'm going to use is just 70% alcohol. You can get this in gallons, order it online for $13 a gallon, and that is 10 cents.
Mind just switching
okay?
chairs.
Not to mention the fluids burn a lot slower
that one, I
than a
take this
viscous
one.
gas, okay? So what I do is I actually take out the cardboard section of the toilet paper, and we might have to remove something. It's not all going to fit. Okay?
Is that your fuel?
This is actually the wick. So we're going to use it as the wicking material. I hate to do this to a perfectly good roll of toilet paper, but I have crops to save. And a few animals that would actually be, actually I grow certain types of rare life forms. I have rare species of ants and rare species of a type of fungal coliform that's used for medicine, okay? So I can't let them die. And well, the heating for the new building that I just built it's simply it's simply too costly to continue that. So we have to remove toilet paper. I would have actually preferred a paint can or a coffee can for this, but this is what I had for the demonstration. Is a Campbell's cream of chicken can left over from last night's dinner. Okay, so gotta remove just enough.
In terms of time, how long will this last as fuel?
So
in a
the
way?
coffee can, and that's without a controlled damper on the top, and I'm going to show you and talk about that. The coffee can version of this without the technology addition that I'm going to show you lasted for 4 to 5 hours. Okay, now that's without any dampering effect. There's two ways to damper this. One is right here. It also helps control this from charring. You don't want this to char. So removing a lot of toilet paper, I guess we could have heaped it a little bit more, but we'll use that for something else. Okay, probably the larger version of this. Okay, there it goes. It actually can fit in there. You have to kind of stomp it in. And what you have is a kind of a controlled wick, okay? What we do with this now is to control how the fire is going to burn in here, I'm going to add some gravel, okay? Now what the gravel is going to do is two things. One, it's going to prevent the flame from actually reaching the toilet paper wick, okay? It is also going to control how tall and how high the flame gets. So you can actually add these to control what flame they are. The other thing that you can do is you can create sort of a lid system with varying sizes of holes to control how much fire actually burns, okay? Now, we're actually almost done with this. So, believe it or not, there are some gentlemen out in the freezing cold of New York right now who are utilizing this technology. And it's a surprise that they can use some of the things that they might drink, okay, to keep from freezing to death at night. And they're using actually no difference from the ratio and comparison of the fuel, okay? So standalone, what we do, I put this on a ceramic plate for temperature protection. I'm actually going to amp this one up. So there's a lot of detection that I found with this. I found that there is some inefficiencies, and I'm going to show you what I mean. Now I'm going to use this entire bottle of 70% alcohol. Okay, you kind of let it soak in. Now these aren't just good for cooking. I mean, well, I was about to say they are also good for cooking, but they're not just for heating. They can be used to provide a little bit of ambient light, okay? And I'm going to show you how to make it twice as efficient, okay, for heating the room. And it's actually not the room you're trying to heat. You're trying to heat the people inside the room. Now, most heaters are actually inefficient, especially electric heaters, because it heats the air. Now, air, when it gets hot, it rises. And once it hits the roof, it transfers that heat energy to the open atmosphere. Therefore, the energy is lost. So the thermostat kicks on, or you turn the heater up, and well, that's you paying for more energy. Okay. So a little bit more. Okay. A little bit of patience on this part, but you know, we have someone who's growing tomatoes in an indoor greenhouse, okay? And they're going as far as buying big barbecue grill tanks for propane so that they can keep the room warm to prevent the frost that is going to happen now this month, okay? I think that should be enough. So I was thinking I was going to have to use some more, but I think that'll actually work for demonstration purposes. Okay, so I'm going to let it soak just a little bit. And what's happening is the toilet paper is actually drawing in the fuel. And that's good because we don't want it all to burn at once, okay? And what I'll do is kind of soak this a little bit and light it. Okay. Provide a good ignition source here. I was actually thinking that. You might have to do it. Alright, so what we get is a flame. Once it goes, and I might need to add a little bit more fuel. Looks like. Once it starts to go, no heat. It's pretty flammable, actually. It's actually a byproduct of something called propene and water. They vent a gas through water and it generates this stuff. Now they get this stuff from a natural source as well as, so let's try like this. There we go. So that started. Now what's going to happen here is this flame here is actually drawing in air and heating it, and it's being released, okay? So it goes straight up. Now, if you stand close to this, so you guys can get closer, you can actually feel what we call radiant heat coming from it. It's not very much, okay? And, well, for some people, it's actually a difference of life and death because when you go out in New York, it gets a little cold, okay? The technology that I'm going to be building this up on is based on what we call a Cornish heater, okay? Now, the Cornish heater uses ceramic flower pots. Now, normally they use a candle. So one of these on your desktop, you'll notice that it keeps it kind of toasty, okay, with just a regular candle. Now, what we have here is I'm going to take several of these flower pots and I'm going to join them together with a bolt, like this, okay? So small inside the next largest, and then so on and so forth. And what we do with this is we make a stack. So what now the air is going to be forced to do is it's going to fall inside the container, roll its way out, and then to the next container, roll its way out, and then so on and so forth, and then finally get released into the open atmosphere. There's going to be an effect that this actually does. When this heats up, due to that, it becomes a certain type of heater. It's an infrared heater, okay? Now what that means is instead of heating the air, it actually creates a type of invisible light that when you come in close proximity, now I can feel heat here, okay? If I add this, you come in close proximity, right about here, you can actually feel that heat, okay? So if you have your tomatoes growing or something like that, and you have your fuel backup, or let's just say it's an emergency situation where you have no heating, no light, this technology could save people. I really wish people during Hurricane Katrina actually had access to this. So I'm actually going to put this on top, okay? I'm trying not to damper the flame, and you can see the flame kind of coming up because fire is trying to get out. That's its whole job. It's once its combustion gets to a certain point, it's trying to get. Yeah, you'll have to have air, a place to go in there. So right now, if I wanted to increase the effect of heating this ceramic, I can place this on top, and the air is going to have to rush in from the bottom now, okay? Which also causes it to circulate out that way. So heat retention, okay? That's the process that we're going for.
Do those two coils serve a function
other than
None,
spacer?
none, just a spacer. So I didn't have anything fancy to bring with me for a spacer. It actually looks like I need a little bit more of a spacer. I should have brought a cat food can or 3, okay? So I have a couple cat food cans that would have actually worked really good for that. Now, what's going on here is the heat's now, well, it's being redirected now, okay? Now imagine this, imagine a couple layers of this ceramic, and what you have is a density thermal storage, okay? Now there are people that do not have heat, and I know in this valley, okay? Imagine the difference this could make for those individuals, okay? Imagine those farmers, we still have farmers who are growing something really nice, but that's the only heirloom seed or the only income they have, okay? This could increase their yield just by adding something. Now, it doesn't have to be alcohol. We've seen this done with quartered wood, so people actually saw little notches into wood and it burns at a slow repetition rate, okay, so you can use wood, or you can use hydrogen, and oh, wow, okay, this really did increase it, so I didn't pay attention, so I'm actually going to unplug it, and you can actually see the bubbles continue a little bit after this. So this tube is actually full of a very extremely flammable gas. To give you an example, if you've ever heard of Hindenburg, okay, that's what she was full of. And, well, it wasn't a light fireworks show, let's just say that much, okay? It was one heck of an explosion. It was heard for miles, okay? It's very reactive stuff. Now, imagine that you use a solar panel as the electricity source to create the hydrogen, and you store this hydrogen inside vessels. So now you got to learn a little bit more about tooling, get a little bit more advanced in the shop, but you use that as your heat source. So you have that inefficient wood stove now. You replace it with maybe not such a small pot, but let's start stacking these technologies together, okay? And you have now a heater, for one, that runs off of free energy, okay? 2, it's not polluting the environment. And if you're even clever enough, you could actually take the vapor that comes out, recollect it, and use it as drinking water, pure drinking water. Yeah, so
This is almost certainly patented, right?
I'm going to give you one answer for that. If we continue taking technologies like this that change the world and try to pump as much profit out of them as we can over and over again, all we're going to do is get this technology, which actually, yes, at one point in time was patented by an Amish inventor. It was a heater based on ceramic output. Now, if you guys want to come close now, just put your the back of your hand close to this. Now, this is only one layer. You can feel heat coming from this.
So it's now public domain because it was patented so long ago.
What I'm saying is anything that I add to this, I'm going to make sure it stays public domain. And we can't have people not being able to do this. But let's talk about this, even if it weren't. Who can stop you? Really, who can stop you?
Well, pretty much, unless you put it on the market,
The heater gets stopped up.
So, yes. So what I would do to increase this effect, so I might have to, because of stability reasons, remove this. Okay, now, just the ceramic alone has stored some heat, okay? And you can actually feel it coming out of the ceramic. Instead of being an air heater, it's a person heater. Yay! We've changed the problem. As you can tell, the flame's still going, okay? Now, what we do to increase the efficiency of this, I have a medium-sized pot there, is the first layer starts with this little itty-bitty one right here, okay? And then second layer, then third layer. Now you obviously bolt these together, okay? And then final layer, that goes on top. I'm gonna hoist it just a little bit, maybe at the same height as the can, okay, to allow some better airflow. I'm gonna play around with it. And after that, what we do is we start making it better. So propane is, or methane, there, I'm ahead of myself. Hydrogen, and this still is generating, look at that, it's still making bubbles. It's still making bubbles. It's not plugged in anymore, and it's still making gas. So something we did last night made that different, and I think it is that aluminum foil on the top, okay? It's storing wasted energy. Normally makes heat. I'll bet you it's cooler than it was last night. So getting ahead to what else we could use. There is a solution to the fuel problem. It's standing right underneath you. Every time you flush your toilets, you're actually flushing enough energy away, every time, to light a light bulb for a week. When your stuff goes into the sewer, okay, or when cattle and all their material gets scooped away, there's something else still happening, okay? There's a bacterial breakdown. It's a anaerobic bacterial breakdown which turns the waste into methane, okay? Methane is the second cleanest fuel out there because 60% of it, when it burns, to 70%, if you round up just a little bit by one, is water vapor. So imagine right now, New York, they have to, what we call, flare this gas out of the sewers. You ever hear of a manhole fire? Well, that's because if someone throws a cigarette down there during a time where it's plugged up during a rainstorm, all that pressurized methane causes an explosion. You can actually watch a couple of YouTubes of manhole fires popping off the manhole cover in sequence. Boom, 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 all the way down, okay? Now,
What's the first cleanest, by the way?
with hydrogen.
Oh,
So hydrogen is the stuff that we generated here. This is actually making a little bit of carbon dioxide, okay? But it's an alternative energy because it's not the status quo energy. You do not pay an arm and a leg for the fuel, okay? So now, imagine.
If you breathe hydrogen, will you sound like you breathe helium?
No,
No?
different
Never mind.
gas.
Sorry, go away.
Different gas altogether, but good question. Turns out this methane that we are flaring up into the air, if you do not burn it, it actually has 40 to 70 times the greenhouse effect than carbon dioxide. And it stays for an additional 100 years in the atmosphere till it finally does decay by hydroxy radicals into carbon dioxide, okay? Which means that even after it's decayed into carbon dioxide, it's still producing the greenhouse effect. So it's actually a responsibility to use it as a fuel. Now, there is a technology, if you guys want to look it up, I will be doing some videos, recording on they're called methane digesters. And what they do is they use compost, okay, and waste to produce a gas. Now, taking it to this technology, this winter, everyone's bill is going to go up. Okay. Imagine having propane or methane available at all times for your home. The technology is simple. You can start with a 5-gallon bucket. That's what I love about this stuff. So, answering the question, are there patents on this? Who can stop you? Who can stop you? What I wanted to show you guys today is the beginning of an exciting new trend we're going to be doing here at Luna. We're going to be doing classes on alternative energy. I'm going to be linking them into my technology classes as they are. Today is our soldering class. So these gentlemen in here know how to solder wires together. Now that helps when they want to go into the solar industry, if they want to, or if they want to do stuff for themselves at home. We're going to talk a lot about this type of technology. Oh, and I do have to go over how you put it out. You simply cover it. Okay. And there it is.
Grab the oxygen.
Yeah. So that blasting heater that we had, giving out all this, it's warm, okay? Giving off all this energy was actually successfully warming this room here. Okay, now the real test is I have a very air leaky RV shed. I'm going to be placing this technology in there after I attach these all together. I might even just do this one before I do that one to do a comparison. And there's a calculation to figure out how many BTUs a heater puts out. What you do is you calculate how much air volume you have. So that's length times width times height, okay? And there's a little formula you can find on the line. And when you change the temperature from the normal ambient cold temperature to another temperature, you use that as the input to figure out what the BTUs are. Now, we were looking at the BTU for a single candle. We're talking about your Luminario candle. That happens to be about 800 BTUs, okay? Now, what happens, though, is a lot of it gets wasted in the form of rising air, and so on and so forth. So if you can, now there's a lot of talk about how the Cornish heater isn't the greatest thing in the world, it's a bunch of hype. Well, yes, if you're using just a tea candle. Now if you use something like this to help make it more efficient, then it's not an inefficient technology.
Do you suppose channeling the heat to heat sinks or a radiator can retain some of the heat?
Yes. And if you can store it, so this is not the best heat storage. It disagrees with me, but it's not the best heat storage material. It turns out salt water is. But I still feel heat coming from this. The flame is off. Do we understand what that means? It's a heater still, okay? So now I promised that I was gonna blow up some hydrogen for you, so I gotta, honor my promise. That is about and counting, it's still making hydrogen, but I have to,
Can I breathe the oxygen?
no. Well, yes, you
Well,
could.
that's flammable too, right?
This is the flammable, no, hydrogen, oxygen is not flammable, it simply makes things burn easier.
Oh.
So in the presence of a fuel, the oxygen will actually make it burn hotter. That's why they call it an oxidizer. It accelerates the combustion reaction because it is what is required for the combustion reaction. Okay, so this thing's been kind of stubborn. I might have to light it with my lighter. Running out of power on that, so I'm gonna have to light it with the lighter. Okay, and what I'm gonna do, you hear that pop? That was a explosion, combustion. Okay, so replaces what's in the cylinder, and definitely replaces even the purchased fuel, although it's cheap, okay? Compared to what you would have to pay for a tank of propane, okay? So better technology, and the good news is when it breaks, you know everything about it, so you're not gonna pay someone to fix it for you. That's what I have for you guys today. Thank you for joining us, I appreciate it. And we're gonna stop filming.